Let's look at what it means to be even, odd, or neither. A function can be thought of graphically as being even if it's symmetric over the y-axis, meaning that when I look on both sides of the y-axis, I see the same graph. The most basic even function you will encounter is the function y equals x squared. If I look on the y-axis, I could see a mirror image of the graph on both sides. And that's what it means to be even graphically. We could also look at some trig functions that are considered even. The most common even function in trigonometry is y equals cosine x. Here is the main period of cosine. It looks like a cup. And if I were to sketch another period on the left side of the y-axis, it would be identical. So cosine is said to be an even function. Some functions are not even, but they do have some other symmetry. A function is said to be odd if it's symmetric about the origin. When you think about symmetric about the origin, just imagine you do a reflection over the y-axis, followed by another reflection over the x-axis. And if you see an identical copy of the graph in the two reflections, then your function is said to be odd. The most common odd function you will encounter is y equals x cubed. Let's look at this function, apply the two reflections, and see why it's odd. Here is the first half of the graph, y equals x cubed. I'm first going to do a reflection over the y-axis. I'm going to do a dotted curve because it's not the final finished product. So I'm going to reflect this graph over the y-axis. And then I'm going to take this new graph and apply a reflection over the x-axis. Okay, so if I took this and I did the reflection on the x-axis, it would show up down here. And that's the second half of the y equals x cubed function. See, that's y equals x cubed. So it's odd. Another good odd function you should know is y equals sine. If you look at sine, the sine curve, it doesn't have a symmetry over the y-axis. But if I were to do two reflections on this sine graph over the y-axis, then the x-axis, it would form this piece, which is another period of sine. So sine is an odd function. Then we have functions that are neither. These functions are still important in mathematics, even though they don't have any reflections. Y equals e to the x, or any exponential function, would be neither. These exponential growth or exponential decay functions don't have any symmetry. Here's y equals e to the x. With the base e greater than 1, it's exponential growth. But if I had exponential decay with the base less than 1, it still wouldn't have any symmetry. And then there's logarithm functions, which are inverse of exponential functions. And therefore, they as well don't have any symmetry, right? Logarithms, they have the property that you have to have a very high increase in x to see a tiny increase in y. These are neither. They're not odd and they're not even. Now, this is a graphical way of looking at it, but we could also do these algebraically. Algebraic definition of being even is that when you change x to a negative x and you simplify that expression, at the end, it's going to come out the same as the original. Now, this name even, you can imagine there has to be some logic behind it. It's even because most of the time we see even exponents on the variable. Here's an example of an even function. X to the 4 plus x squared. I'm going to replace each x with negative x, and I'm going to simplify it. When I take a negative number to the power of an even exponent, the negative goes away. I have x to the 4 plus x to the 2, and that's the same as the original function. So this is an even function. Now, they're not always going to be this simple because, for instance, if you look at the cosine function, we've already established that graphically, this is an even function. It's symmetric over the y-axis. So we just have to accept that when we change x to a negative x, cos negative x will just be the same as cos x. And we just accept that without doing the algebra as we did over here. So here's an example of an even function that could involve cos x. Let's say x to the 6 times cos x. If I replace each x with a negative x, I'm going to have negative x to the 6 times cos negative x. Simplifying, I'm going to have negative x to the 6, a negative to the power of an even number is positive. And then cos negative x, cosine is even. So it's cos of x. And this is the same as the original. So my function is said to be even. Odd functions. A function is said to be odd if replacing each x with negative x, as you simplify, the answer becomes the negative of the original. Okay, here's an example. Let's look at x to the 3 times cosine x. And even though cosine x is even, the overall answer will show us an odd function. Let's see why that's the case. Replacing each x with a negative x. Here's what I have. Negative x to the 3 is negative x to the 3. So this time the negative will stay. A negative to the power of an odd number will remain negative. And if you forget these properties, it's okay. You just got to test it out with numbers. Negative 2 times negative 2 times negative 2 is a negative 8. So the negative will survive, will stick around if you have an odd exponent. We know that cosine is an even function. So cosine of negative x is cosine of x. And look at that. Comparing this to the original function here. It's the negative of it. And that's what makes this an odd function. A function may not satisfy one of these two properties. And in that case, we say it's neither. So to be neither algebraically, it means that when you replace each x with negative x, you don't get the original function, but you also don't get the original function with a negative factored out. This would be neither. Here's a good example of this. Let's say I have 2x to the 2 plus 3x. Replacing each x with negative x. When you take a negative to an even power like a 2, the negative goes away. I have 2x to the 2. But in this last term, positive 3 times negative x is negative 3x. Okay, so compare this to the original. It's not the same. But maybe if I factor a negative, the rest will look like the original. So I will try that. If I take out the negative, it's going to be negative 2x squared plus 3x, like that. Okay, but even then, this is not the same as the function. So not only is f of negative x not equal to f of x, it's also not equal to the negative of the function. Therefore, this function is neither odd nor even.